So I referred to a quadratic function at the beginning of this because these parabolas that we've been talking about, these are the graphs that you get when you graph a quadratic function. But before we go on with this, it's important for us to have a more careful definition of a quadratic function. A function is quadratic if it can be written in the form y equals ax squared plus bx plus c, where a, b, and c are real numbers, and it's important that a is not 0, because if that first coefficient is 0, then we don't have the squared term, so it's no longer a quadratic function. So in each of these examples, what we're really going to be looking for is what are the powers, what's the highest power that I have on my x and y, and is there sort of anything funny going on that doesn't make it look like it's of this form. So on our first one, this is linear because the powers for both x and y are both 1. And for part B, at first glance, it looks like x is to the 1 power. But if we expand this a little bit and we distribute the 2x through to each of these, then we notice that actually my highest power for x is 2 and my highest power for y is 1. And therefore, this is quadratic, because I can now identify this as y equals 2x squared plus 6x plus 0. So in this particular case, my a would be 2. Let me change that to highlighter. My a would be 2, my b would be positive 6, and my c would be 0. So I can get it in that form where a is not 0, and I can identify a, b, and c that are real numbers. And it's worth not only saying, yes, it's quadratic, but going beyond and identifying a, b, and c, because that not only reinforces that you really are checking to make sure it's quadratic, but it also prepares you for the next section. All right, looking at c, even if we simplify this, we still have highest power for x is 1. So this one also is linear. And for this one, we can write it as 2x squared plus 0x plus 3, which means that it is quadratic. And if I need to, I can identify a is 2, b is 0, and c is 3. Now for this one, it's not quadratic, it's linear. And even though that square root of 3 is kind of ugly, it's still linear because the square root of 3 is a number. For part F, the highest power is 3. So this is not quadratic and it's not linear. In fact, we call these cubics. So this is neither of those. And this square root of x is also neither linear nor quadratic. We call this a square root function. And finally here we have x squared, but do you see how it's down in the denominator? If we study rules of exponents, this actually means that this is x to the negative 2 power, not x to the 2 power. So this again is neither. So this would be a good opportunity for you to go practice. You can turn to page 552, number 16, and just kind of check along with the videos and make sure you can identify whether a function is quadratic or not. And that's the end of topic 16.